Welcome back to this edition of Elementary Grades Computer Science webinar series. Today we're going to focus on programming concept and skills. I'm breaking this into two parts so we can get into some of the coding aspects of and skills concepts that you may want to integrate or use in your technology classes in K-5. So going back to the frameworks and the practices that we've been discussing, the practice that aligns mostly with what we're talking about today is developing and using abstractions. And abstractions are, think of abstractions as generalizing in order to make complexity simple. So simplifying complex information or data or even code to make it more simple and to be generalized to execute a specific function or solve a specific problem. So abstractions, kids are doing abstracting all the time, although the younger kids have more difficulty doing this, especially in classes such as science or math, when we're playing around with numbers and phenomenon or concepts that really aren't seeable in the real world, and then having them apply that information, make sense of it to coding is very difficult anyway. But for the little ones, it's especially difficult. But even for them thinking about how they tie a shoe and the process they take to tie any shoe that they have is the same. So that would be abstracting, doing an action or process that's for all shoes, applying it to some particular event. So really by the end of 12th grade, we're looking at students extracting common features, usually at a big data set or something in a long series and line of code, evaluating and incorporating some technological functionalities, looking at technologies and evaluating it, and then incorporating pieces into something they're creating, and then creating interactive modules, something for others or other users to tinker with, and then modeling or simulating phenomena, processes, and systems, which we've talked about before. But in particular today, we're looking at specific computer science concepts around algorithms and programming. So just to break it down, programming in layman's terms is students are writing step-by-step instructions. They are telling a computer what to do, but they have to communicate that in a way that the computer understands. So the language or code that's written deciphers what those instructions are for the computer, right? And then the algorithms are the sequence of steps involved for the computer or software to be the program to actually execute. And then this control structures we're going to talk about that a little bit more today, but that specifies how these sequence of steps are enacted, and they specify the order. Okay, so that's high-level concepts we're talking about today. And in particular, we're going to hit events, loops, and conditionals in application to K-5. So if you're a teacher just looking to integrate some really cool computer science stuff, don't let the terminology scare you. We're going to go through some code.org lessons and just show you what this stuff means. But the events, we're talking about actions that cause something to happen. So the sequence of steps, so the events being the steps that are involved. Loops, we know what a loop is something that plays over and over and over, a broken record. And so those are when we're programming, and those are the code. That's the code that we specify to do one particular task over and over and over. And the conditionals gets into specifying particular actions that occur only when certain conditions are met or certain parameters are met. So we're going to focus on code.org to discuss some of these. I want to put this in context of some research that's out there. Always try to link the research into why are we doing this? Is it going to help us? Is it going to help our students learn? What's out there that shows some connection between what we're trying to do and learning? So there was some recent research that came out that looked at teachers that were integrating code.org lessons, which I'm going to show you those specific lessons today, with science, social studies, and ELA. So they were actually creating lessons that were transdisciplinary, brought in the content standards, and then they pulled in code.org lessons that were associated with that content in science, social studies, or ELA. And then they also looked at a wider group of teachers, including these, and had parameters around how many code.org lessons were being implemented, were there extra code.org lessons, and some other teacher dispositional stuff. So the lessons that they looked at for elementary grades can be found here, and I'm going to show you those in a second. Just go through the findings real quick. And I was actually a little surprised by the findings, and these are preliminary, so they haven't actually published yet, but they're, so far what they've been able to find is that the integration condition, the teachers that were just doing the integration, and again, that was, they were integrating code.org lessons, associating those with those in grade levels with that particular content in those 3 subject areas. They didn't find any significant differences between with the kids in their literacy, math, and science scores. But what they did find is that for teachers that pulled in extra code.org lessons, they had their kids do mini code.org lessons and additional activities, and certain teacher characteristics, which were years of teaching or integrating computer science, the teachers rating themselves on how innovative they were and how resourceful they were in the classroom and able to cope with change, was associated with higher scores in literacy, math, and science. So what does that mean? So that means that there's some evidence right now that shows that these code.org lessons, when they're used in quite a bit of fluency in the classroom, are associated with higher scores in literacy, math, and science. So why weren't these results found in the integration group? And the integration group, they integrated these subjects, and they also they associated those subjects with specific code.org lessons, but there wasn't significant differences in their test scores. What I wonder is, to what level was this content integrated in a way to where students were actually grappling with the content standards and thinking about the content standards and focused on those content standards and using computer science to help communicate those standards themselves and actually having some level of control of that. So this isn't the findings here do not say that computer science integrated in academic subject is not going to is never going to help students learn content, let's put this in context with some other research. So what we do know, and there's quite a bit of research on this, that when students are integrating and using computer science principles to help them learn specific content standards or specific subjects, and those are designed, that learning experience is designed in an intentional way where the students are actually creating their own artifacts and integrating these principles with the content, then there are benefits. So I point to one particular study in 2015 that looked at constructionist games. So these are games that students create. There's parameters around how they're creating them, and then they're actually, the teachers are requiring that the students integrate specific elements or standards into those games, and those are used as a supplement to science or usually STEM instruction or some academic instruction. And so this study found benefits in learning effects related to science, math, ELA literacy, fine arts, particularly visual arts, and other STEM subjects such as astronomy and earth science and those kinds of things. So it at least what the research is telling us so far is that it's not just tacking on lessons in computer science. It's intentionally designing learning experiences for students where they're grappling with the content, they're thinking about their products, and they're integrating those standards in a way to where they're making sense of it and communicating that. And communicating that through their projects, through their interactions with their teachers, their peers, and we've been talking a lot about the Scratch platform, which is a great platform to share projects and then receive comments and feedback and modify those things. So I've included both of these studies, and that information is here. And read at your leisure and look at some of those specific studies within the 2015 meta-analysis, and you can find some specific lessons and stuff that can benefit you. But I just wanted to talk about the research for a second. And we're going to move on to the code.org lessons that were found to be to show clear benefits to particular academic subjects with teachers that are really trying to break through, be innovative and resourceful, and cope with change, and have years. The more years that you have teaching and experience with integrating computer science, the more learning effects that will be found, at least preliminarily, from what we're seeing with this study. So we're going to look at events, loops, and conditionals today. And let me switch to screen mode. Okay, so let's bring up this PowerPoint again. And we're going to look again, we're looking at the cross-cutting concepts with practice number 4, abstractions, and focusing in on algorithms and programming, and looking specifically at control and the control flow, how a program is actually working, and how it flows. And 3 computer science concepts we're going to focus in on today are events, loops, and conditionals. So we've talked about this code.org website, which has tons of free stuff for teachers to use. You can see here lots of stats on this, And if I'm an educator, elementary, middle, or high, I can actually find some lessons on here that are free. So if I'm in kindergarten, first, second, first through 5, there are different courses that go with those. And then there's an express course that kind of hits a lot of different areas, topics in computer science. We're going to hone in on course D today. So this is 3rd grade. In Georgia, we know that they're testing in 3rd grade, so this might be a good grade to begin to integrate some of this stuff and have students begin to go through some of these lessons. You can see the lesson plans, which focuses here, programming on graph paper. I love these, by the way. Anything that links computer science, coding to how to graph. We talked a lot about this in some of the earlier modules on graphing data in math and science and even other subjects. And here you can see lesson 3, we're looking at events, and then move on to loops, and then we're going to focus in on conditionals. So these are progressive lessons that students can do, and they actually have video that we will go over as well and let you see that. So these were going back to linking this to the research I talked about earlier. The lessons that they associated with those subject areas and integrated were found from this website. So again, we're looking at events, loops, and conditionals. And events, we're looking at a series of actions that cause something to happen. Loops, some action that does some function over and over. And conditionals, there's going to be action, but only under certain conditions. Okay, so let's start with events. All right, so this is telling me to attach a block when left arrow block and press run. So I'm trying to reach the finish target. So I'm trying to get this, and you can actually read it.
Block and press run. Move the panel using the left arrow to reach the finish target.
Reads to students, and they can actually hear the audio of that. I'm going to check if the audio was heard. Okay, so now when I'm pressing the left arrow, it's my command, I'm going to move left or right. So let's just start. Students will play around with this a little bit. They may move right. I'm going to move right again 3 times. See what this does. So it moves, it looks like it moves 3 spaces. Let's see if I move right, it's going to move, reset this. So I can control this 1 space, I can control this 4 spaces, which is not going to give me to my flag, so have students play around with this and use their keys to see if they're on the right track. So I'll reset this and now run it. What this does. So I can move one at a time, or if I wanted to, I could move all at once. So that's important for students to see as kind of a prerequisite towards loops and conditionals. So I completed puzzle 1. And in this case, when I'm moving, when I press left arrow, I can move left, and then I can move right. That gets both functions going. And so the idea here is that I'm moving, getting used to two-dimensional space and movement in two-dimensional space, but also events of moving in a particular direction for an extended period of time. So let's just play around with this and see what happens when I press the up arrow. Looks like not doing much. Now, when I press the up arrow, I move right. That's not working. Well, it's getting confused. So clearly we want to just move up here. All right. So that's a neat little lesson on events. Let's look at loops. And this one we can see is more complicated. Actually, let's go back and just take a look at this. I want to make sure that we didn't miss a video or something like that. So okay, so we're on the right track. All right, so here it's going to be great to have the bee collect all of the nectar. So I need to move this bee across. Now I know how to move. I've had some practice with movement. And it looks like I'm running. So I'm going to run forward, turn right. I can get nectar. I can turn left. So clearly I'm going to go in a circle or a square, but I need to just keep moving. So let's just see what this does. I can move forward or backwards here. Let's do, what if I move forward 50? I move twice, but something else is not working right here. Let's try repeating this. Yep. So now I'm just ran into the tree. So, okay, something's not quite right. I'm not getting the nectar. So let's start over. I move 2 spaces. Then I get the nectar. Let's see what that does. Okay, so students go through and just begin to play around with the code. They can see that they're not being successful moving forward. So I've got to somehow keep moving forward and then for an extended period of time and collect some nectar. Let's try move forward, get nectar. Let's reset it to see how many. And then I'm going to repeat that. And every time that I move forward, I'm going to try to get nectar. It's going to do the same thing that I did earlier. Nope. I've got to actually get to a flower. Can't get nectar unless I'm at a flower. So let's just look at moving forward once, moving forward again. Then I'm there. Then I'm going to get nectar. Oops. Make sure I'm on the right path here. Okay. So let's reset this. So I got nectar here. Then I need to move forward again and get nectar. Then I'm going to need to turn right. So let's see where that gets me. Okay, then I have to move again. Turn right, then I'm going to move forward. One space, move forward 2 spaces, and I'm there. Get nectar. Move forward again. I'm here. And get nectar. Okay. Then it looks like I need to turn right again. Move forward 2 spaces, like I did before. Get nectar. Move forward and get nectar. Okay. I could have used, the cool thing about these lessons is that I wrote 17 lines of code, but I could have used only 15 blocks. So I can show code. This is what I wrote. Okay, where was my... All right. So notice that it saves what you've worked on. So it looks like what you want students to see here is that this code looks like this code looks like this code, right? So that line of code, I can modify this. Well, I need to turn right, don't I? Ugh. All right, so then let's just try this here. And then I need to turn right. So put that in. But now I want to actually run a loop. Okay, so the idea again, we have something that is seemingly complex. I'm going to simplify this as a loop. Woohoo! 7 lines of code. That's awesome. Okay, so those were loops with bees. We can play this for a second. So actually teaching what I was just talking about there. Okay. So let's go to conditionals. And this one's a bit harder. Okay, so this says the cloud is blocking the view. There could be a flower under this cloud. I don't know what's there. But if there's a flower, the bee will need to collect nectar once. So if the bee lands on here and there's a flower, then the bee should collect nectar. If there's not a flower, should do nothing. All right, so this code says when the bee runs, it's going to move forward 3 times, 1, 2, 3. When the cloud reveals itself, if there's a flower there, get nectar. So I think that the bee will move and get nectar if there's a nectar there. Okay. So what I like about this lesson is that there is a video. If students run into any trouble, which their third graders will inevitably run into trouble with this unless you've been practicing with them for some time on some other code, but they'll surprise you. And I'm going to say I want a hint. Okay. So B's going to move forward twice. Looks like turn right. If there's a flower, get nectar. And looks like there's some other code in here. So let's just try this. Move forward twice. I'm going to turn right. Then I'm going to move forward. So let's see where the bee is now. Okay. Can't leave any nectar or honey behind. So let's try this again. So far I'm here, and when the cloud shows me something, if it's a flower, I want to get nectar. So it looks like I need to move forward again. And then there's a flower there. So if I'm at a flower, get nectar. Okay. I could have used only 8 blocks. So let's see if I can change this. So this code is the same as this code. If I repeat this, let's see if that fixes it. And repeat it twice. Reset, run. Okay. Try it again. They got rid of a flower. Okay, so you get the idea there. All right, so here, conditional, I'm going to run. When I run the program, I move forward. While the path is ahead, we'll play around with that too. But so it looks like I'm not turning, I'm just moving forward. I'm going to repeat that. Let's do that 10 times just for simplicity. I don't know how many times I have here. Okay. So this just has my bee moving forward. Looks like I'm moving forward. If I could move 10 times, I would, but I'm not collecting any nectar along the way. So if I'm at a flower, I want to get nectar. Let's see what that does. Okay, so I ran into the wall. It looks like I am repeating this too many times, so let's count my spaces. 1, 2, 3, 4, 5, 6, 7. Let's try 7 times. Okay. All right, 4 lines of code. Let's look at this other one. So this is the same thing. Every flower has 1 nectar, but they're not spaced out. 1, 2, 3, 4, 5, 6, 7. If a flower, repeat. I'm going to do this 7 times. Oops, I lost my move forward. And then get nectar. So this is the same thing. So they're making sure that I didn't get lucky on that first round. Okay. So these get more and more complex. You can see here that I'm going to have a turn. Let's just go ahead and do this one. Move forward twice. Turn right. Then I'm going to move forward. Looks like 1, 2, 3, 4, 5, 6 times. And I want to get nectar if I'm at a flower. I'm going to repeat this. How many times? 1, 2, 3, 4, 5, 6 times. Okay, see if I'm on the right track. Whoa, what happened? Oh, I see. It's actually moving down. So forward is down here, so I'm really trying to do this. Okay. So then I need to turn left. That one's kind of confusing. I have to rotate that in my mind. And then move 2 spaces. Then turn left again. Then it looks like I'm going to do this again. So let's do move forward. If that flower, get nectar. See what this does. Okay, that didn't work. Let's pull this off. Okay, so it looks like I did not do my move forward. See if that's what it was. Okay, then I need to collect nectar. So, I'm not really sure why this one didn't work. Let's just keep moving forward. Pull off the turn right, see where we're at. Then if I want to repeat it, I can. Okay, so I'm moving forward, but I want to keep moving forward. And I'm at a flower, I want to get nectar. Let's just do this 2 times. Okay, now I'm on the right track. That was 2 times, 3, 4, 5, 6 times. She did say, talk out loud. Run. Okay. All right. I could have done this in 7 blocks, so I'm going to leave that up to you guys to figure out with your students. And let's recap today. So we hit on events, loops, and conditionals. As you have your students work through these code.org lessons, think about how you can relate that to your content. This will give them some skills and some basic computer science concepts for them to work with, and so that they'll be able to code elsewhere. And what we'll do next time is we will take some of these concepts and apply that to some constructionist teaching methods in Scratch, where you can scaffold some of your standards around a particular project or artifact you want your kids to create, and then they can apply these principles and then begin to grapple with those standards even more. So thanks